All right, so for problem number 1 from chapter 8, it says that it's rotational motion. So it says that, let me read it out loud and then we'll think about it. It says, a wheel rolls uniformly on level ground without slipping. A piece of mud on the wheel flies off when it is at the 9 o'clock position. So this is our wheel, and the 9 o'clock position is here. Okay, so it's on a surface and it's not slipping and it's rolling across the surface, and a piece of mud falls off right here at 9 o'clock. Right, so it's like 12, like this is 12 and this is 3 and this is 6. That's what they're talking about. And so the question says, a piece of mud falls off or flies off the wheel at the 9 o'clock position. Describe the motion of the mud. So I've got a little piece of mud. That's close. Well, that's not quite. What color is that? It's red mud. It's like clay. So this wheel is moving this way without slipping. Okay? The tangential velocity of the wheel is going this way. The rotational motion is rolling that way. What happens to the mud as soon as it falls off the wheel? Does anybody want to? I saw some hand movement. What do you think it will do? Well, what direction does the mud want to travel in the minute it falls off of the wheel?
Same direction.
But the wheel is rotating a lot of ways, right? So what's going to happen is, first of all, the velocity of this is going to be tangential to the circular path, right? It's going to be tangential to the circular path, but it also has a translational velocity. And then there's something else acting upon it. What? Huh? Gravity. So there's going to be, if I think of the mud, this is going to have gravity acting upon it. It's going to have a tangential velocity. And the rotational thing is important, but not really so much. So what would that look like if I were to draw just the mud? Yeah, it would be, so you guys are making it. If this was just a little speck of mud, it's going to have kind of a tangential, and gravity's going to act upon it. It's going to go in a straight path, so it'll have a tangential velocity. So it'll have like a free fall, like projectile motion. It'll have like a free fall. It'll look like this in free fall. Now, so that's kind of what it would look like. And as it did that, the wheel would be in front of it because their translational motion, for the most part, would be the same. So wherever the wheel is, it would be pretty darn close to the wheel, right? Because the wheel has a translational velocity, and that gets carried over too. Okay. So let me read what the back of the book says, and tell me if our picture matches up to what the back of the book says. It says, at the 9 o'clock position, the velocity is straight upward. So it is in free fall with an initial upward velocity. It will rise, reach a maximum height, and fall back down. Does that seem right to you guys? Yep, that's pretty much it. Now, did anybody think of anything different than that? Probably not, because we talked a lot about free fall. The only thing that I think students sometimes forget is that there is a translational velocity component. So its initial velocity is kind of like this. So if we were to actually calculate the math and figure out that free fall, there's like a component part to that, okay? But that's not what they asked us to do.